he is not able to join us personally. He has sent us the audio embedded PPT file. So we can start this presentation on biomass and the biomass and bioproducts. Yesterday it was biomass and bioprocess, so this is bioproducts. So just give us 2 minutes, we will start the presentation.
Hello everyone, I'm Professor Bernardo Dias from School of Chemistry, Federal University of Rio de Janeiro, Brazil. And today I'm going to present my lecture about eutectic solvents and bioproducts in Spark workshop. First, what is bioproducts? Uh, Here a definition from Canadian government that bioproducts are products made with some components of biological or renewable materials. And the bio relates to inputs derived from biological sources, including agriculture, for example, crops and crop residues, dried distilled grains, and or food processing, byproducts, residues, and of specification materials. The forest is another potential source of biological materials, and I can include here the microbial wastes, microbial resources as well, and animal uh, wastes as well. So, some kinds of byproducts uh, only can be obtained using fermentation process like yogurt, vaccines. In this time, vaccines is very important. Uh, and other products can be obtained by synthetic methods and uh, from renewable materials like PLA, uh, biomaterials using poly, polylactic acid that uh, uh, can be obtained by petroleum resources and by renewable materials. And carotenoids is another example. You can obtain here by synthetic methods or by extraction from plant materials or algae. So you have Here are some examples of bioproducts. In this presentation, I'm going to present some raw materials that can be derivated in bioproducts to contextualized. Okay, so you can have bioproducts derived from sugars, monosaccharides, disaccharides, polysaccharides. So you can think in wood, eucalyptus, uh, and then derived from them is paper, cellulose and paper, and it can be just sugar uh, to sweeten our food. You can see here the starch from potato or from corn, cellulose here from celery or other green vegetables. Né? So you have just so similar the structure and between starch and cellulose, just a little uh, change and the position of this hydroxyl group, hydroxyl group, that one in the starch is the position alpha, and the cellulose is in the beta position, and just this only modification modifies at all. So you can obtain many products about from sugars. Proteins. We have some ideas here. We have keratin from feathers, just the raw material from shampoos, actives, and the keratin hydrolysate and shampoos is from chicken feathers. We have mushrooms, very nice, and in butter. Uh, we have silk from insect, the worm of silk, silkworm. We have jelly. It's from collagen from many types of animals. Today is growing the market of fish collagen and deriving gelatin, jelly, and so many options here for food and non-food applications. Uh, we have lipids, uh, just oil, vegetable oil, butter, margarine, waxes, biolubricants, some surfactants that can be applied in cosmetics, many types of cosmetics, and personal care products. We can generate biofuels using lipids, using lignocellulose materials, wastes. So, for example, here the sugar cane. In Brazil, we have a big industry about that, using sugar cane juice, molasses of sugar cane, and many researches about using the sugar cane bagasse and everything to make sugar or ethanol. Some types of uh, industrial plants make only ethanol or sugar and ethanol. Uh, Here in Brazil, we have 10 years ago a huge stimulus to produce biodiesel, like we see in this figure on the top of the slide. But now uh, this is still producing, but not so much with everything. The 10 years ago, if has oil, lipids, vegetable oil, you someone will be trying to make biodiesel. So it's very crazy times. Uh, in other places, you can make ethanol using corn or using of wastes from sugar beetroot. So some other options and many wastes are generating this industrial plant that is raw materials for bioproducts. Other bioproducts that is considered secondary metabolites that that is uh, found in plants and animals and minor concentrations. So you have pigments, uh, just as chlorophyll. Right? So you have chlorophyll from plants and algae, carotenoids. Here, example of astaxanthin present in salmon and some kinds of shrimp scraps, uh, and have many others carotenoids. Uh, you have bioactives that promotes flavor, aroma, that have many types of composition, uh, and many apps like phenolic compounds, terpenes, monoterpenes, sesquiterpenes, diterpenes, uh, and many others are involved in aroma compounds. Here, just an example that sometimes we have many ways to get a byproduct. Like here, the vanillin normally produced by lignin in the chemical process, or have some other enzymatic process, microbial process, using even plant cell culture to produce vanillin, or extract directly from the orchid vanilla. But I don't think that is a very economical way. Maybe just sell with a huge price the your kid. And some byproducts are problematic. Uh, Maybe we can try to extract to just to remove them. Here two examples: the aflatoxin produced by Aspergillus flavus, a fungi that contaminates uh, peanuts, Brazil nuts, and can promote liver cancer in very few uh, concentrations. To, for example, 50 ppb parts per billion. And here the rising, that's a protein called lectin, and present in castor beans, that is a poison. So if you have to work with castor beans, you have to be careful, and the wastes have to be detoxified. when we work with bioproducts, we have some ways to extract and then recover this product. We can extract directly using solid leak extraction with raw material and the solvent. In the case of eutectic solvents, sometimes we just make a dissolution, not a extraction. The solid raw material don't be there, make everything liquid, and then just one phase liquid. Uh, we can use liquid extraction with two phases, and then we have iotic solvent with a molecular solvent. One is hydrophilic, another is hydrophobic. Or we have ATPS, uh, aqueous two-phase system. So you have two hydrophilic phases, but uh, a little difference about uh, hydration, about the salts and polymers. You can make two phases. So you can make Eutectic solvent with aqueous salt solution. The salt, maybe you can use ionic liquid here, maybe, or polymers, aqueous polymer solution, or you can use liquid polymers too. And then a recovery that is uh, has increasingly in many articles uh, the this exigence that include the recovery, not just make all the work with extractions and then obtain the byproducts pure in the end of the work. So there is some type of recovery that you can try. Uh, if you're working with macromolecules, probably precipitation is a good idea with unsolvents. An unsolvent that can be uh, distillate, distillable after the process. You can use distillation to also to remove some kinds of metabolites that are volatile. You can use membranes, ultrafiltration, nanofiltration, evaporation. It's another option. It's more cheap nowadays. Maybe it's not so easy that you have to study the interaction of the uh, membrane materials with the eutectic solvents because you can dissolve the membrane uh, during the processing. So try with small quantities of membranes before try the separation with them. And another option is the back extraction. Uh, if you use hydrophobic solvents, you can use water or diluted acid-base solutions. Uh, are options. Some works try to use resins, but maybe you can go to the same problem that membranes. You have to test solvents with the resins and to know if it's going to be diluted uh, or have a interaction that modify the properties of the resin. Well, in this uh, chapter from Zainal Abidin, They they highlight the problems, the usual problems in the solid liquid extraction. So maybe you have high viscosity, low dissolution, a low mass transfer because of the high viscosity, and a low extraction yield. And then with the eutectic solvents, uh, um, measuring or altering the water addition temperature or molar ratio or composition of the eutectic solvents, you can increase and make a high extraction yield. In the practice is is like that, but you have some problems and sometimes with viscosity too. But the interaction by hydrogen bonding uh, with metabolites really increase the high extraction, really increase the extraction of metabolites. So maybe not because the viscosity, more because the interaction of hydrogen bonding. Here some examples of using eutectic solvents in the extraction of phenolic compounds. So here three raw materials using here pigeon pea, safflower, and Japanese cypress. And then you can see these parameters: the temperature, time, water content, the ratio uh, here, volume, weight, but sometimes weight between liquid and solid. Uh, you can see also sometimes the combination of another green method like microwave or ultrasound, uh, or even enzymes or other catalysts to promote here the not the extraction, not only the extraction in this presence of the catalyst, you can, yeah, reactive extraction. So we have here some good results. Improvement 2 times here in the pigeon pea in the extraction of phenolic compounds. In the safflower, we have uh, the improvement, big improvement of of the of this metabolite, 100 times here in the hydroxysafflower yellow way, uh, 10 times in cartamine, 20 times in cartormine. So you have some good results here. Another option of solid liquid extraction, in this case, is be specific the dissolution of lignin in the from plant matrix. It's very common in the lignocellulosic pretreatments nowadays. So you see basically chlorine, chloride based eutectic solvents being used to uh, to this case with temperature uh, since below 100 degrees. You see here 60 degrees, 90 degrees until 160 degrees. Uh, have some variation, but all have a good delignification yield. So using sometimes microwave too with decreasing time in the process. But in my experience, you can use 110 degrees with 1 hour, and you can obtain a good result. But well, yeah, in Brazil. I work with Brazilian wastes. So you have here many more wastes in this table. Uh, Here we have corn cob, poplar, miscanthus. Uh, in Brazil, you have more the sugarcane bagasse. Uh, we have rice straw, sugarcane straw. Uh, then it's another option. And you can use the liquid extraction. You can in this option use the eutectic solvents, the hydrophilic eutectic solvents, and hydrophobic molecular solvents here, but it's from waste, soybean oil deodorized distillate. It's rich and tocopherol, vitamin A. So here you can see the variation of the ratio of the eutectic solvent to the soybean deodorated distillate, and the better dipalthetic solvent tested was the choline chloride paracresol. Liu and his group tests others eutectic solvents, and only worked with the HBD with aromatic group. So to make this interaction with tocopherol. So they tested para, meta, ortho, cresol, all worked. And you can see that with a proportion of 6 ml of eutectic milliliters of eutectic solvents to 1 gram of this waste can be maximum yields of tocopherol. It's an option. Another option it's the reverse using hydrophobic eutectic solvents and aqueous solution of organic acids. Here he makes in the an extraction column filled of uh, glass beads, small glass beads, 2 milliliters, and then analyze the two phases. But in this case, comparing just with terpene, liquid terpene, and the terpene and the eutectic solid or hydrophobic solvents have very similar results. So more uh, cheap to use the only the terpene here, but he can make all both of them can have a good yield in the extraction of this fatty acid. This organic acid it's not exactly volatile fat. Né? Fat for me is above CH. Uh, Below CH is just organic acid. You can use the aqueous phases here in liquid extraction. Some examples using choline chloride, butanediol with phosphate salt, or here with uh, also another way describe choline chloride, uh, I think, with carboxylic acids and polypropylene glycol, or uh, with propanol and phosphate, and so on. The very options here to extract metabolites using ATPs. Then we try to recover the byproducts from the eutectic solvents. So in this article from Kumar and the group, he showed here the mixture of solids, then the heating in forming the eutectic, adding rice straw in the 2.5 2.5% loading uh, solution in that condition using Eutectic 60 degrees, 12 hours, 5% water, and then uh, adding more water, uh, putting in the fridge for 2 or 3 hours to all the lignin precipitate, um, centrifugate, and and remove the precipitate lignin and reuse the eutectic solvents. It's the option and the more easy option, just using water and cold. My group with Professor Maria Alice Coelho and Professor Isabel Marrucho, we worked with extraction of saponins from sisal, Agava cisalani, that is here, and joá, Ziziphus juazeiro, using colinium-based ionic liquids and eutectic solvent, but we're gonna concentrate in eutectic solvents. Uh, his work is just to compare and optimize the conditions of the extraction. They don't have any part of recovery, so they compare solutions of of eutectic solvents here with water, so half eutectic, half water, and we use the choline chloride solution to compare, and we have some results. For this extraction efficiency is can be higher than 100% because it's comparison with water. So water is 100%. Then we can easily see what is better. Then you see that choline chloride urea is very good, and both raw materials, both joa and sisal. Uh, in this work, we make a partition, not a partition, a distribution in the solutions about the saponins and phenolic compounds. I want only saponins, so we make this uh, distribution. So higher this factor, this parameter here, better, and the cost of these solvents to obtain a 1 ton saponins. Uh, then we compare with uh, eutectic solvent and ethanol water. Using half eutectic solvent, half a mixture of ethanol and water. I think it's 30% ethanol, 70% water, and then we have better results using here with choline chloride acetic acid for joie and choline chloride propionic acid with sisal. And then in this work, we doing experimental design, we do mixture design, but uh, I think I was missing this was the recovery part. So, right, the same approach in the use of tea and mate. Mate is Ilex paraguaiensis is a typical uh, plant in the south of Brazil, but we have beverage make of them that is all over Brazil and Latin America, but, mainly in the south. And tea, tea is known all around the world. So in this work, we try not only to extract the saponins and phenolic compounds in tea and mate, but also recover them using membrane. So try the same how of the eutectic solvents using choline chloride, and somehow some results is good, depending here. I want the two, not only saponin, but saponins and phenolic compounds. So we're gonna evaluate the two, comparing with ethanol and waters, but I use ethanol, the solution of ethanol as 100%. And then choosing the eutectic solvents, we tried the a sequence of filtration and membrane filtration use, microfiltration, ultrafiltration with different cutoffs, and nanofiltration with different cutoffs. Uh, then with filtration and microfiltration is just to remove the particulate, and after before that we use centrifugation to remove polysaccharides, and then uh, try to separate saponins from polyphenols from eutectic solvents. Then we have some results indicating that uh, some materials would be retented, but not have some very good uh, difference between them, indicating that uh, I don't have the cutoff right to make this separation. Uh, in the case of the permeate, comparing here with the result, we see that phenolic compound is decreasing the concentration. So some is retented, but saponins no, it's going to is still going to be in permeate in lower concentration, but still in retentate too. So here the photos about yeah we have so much phenolic compounds here and 10 kilodaltons in the example of the black tea. Uh, we have to try nanofiltrations with mass values, molar values below 500 daltons. In this moment, finally, I have purchased two nanofiltration membranes, and finally, I will end this work testing, repeating some sequences, but using these right membranes of nanofiltration. But just to remember, have to test some types of plastics, the presence of eutectic solvents, but some types don't support and can be kind of corrosive to the plastics, disintegrate the plastics. In this case, not only disintegrate part of that, they uh, uh, swallowing as well. But the company, I have a appointment with this company, and they gave me the this O-ring for free. So this is about I want to tell you. I think everyone is very tired by now. I think it's the last lecture of the workshop. Here is more reference about the subjects if you wanna know more. And just wanted to thank you for your attention. Uh, this is my lab in Brazil that I said before, Clean, Clean Tech, Clean Technologies Development Laboratory. We, we have my email. We now in under construction of the site of this of my lab. Okay, thank you.
Okay, good. Sure. Okay, so participants, so if you have any questions, so you might have noticed the two email IDs. Kindly forward your queries to Professor Bernardo. And with this, we come to the end of this symposium. And the final session is the vote of thanks and feedback session. So you have been already forwarded one feedback form. Kindly fill that up and send us. So before I go for the feedback session, I'd like to thank some of my persons who have been used or been very helpful in this workshop for organizing the workshop. First of all, I'd like to thank the sponsoring agency, Spark, for giving us financial support, and our department, Chemical Engineering, which has given us all the logistics support. And then the wonderful team of this workshop, including my colleague, Professor Partho Sharati Upasagar, and our entire team, especially I'll call out their names. They can put their hands up. Jayant Mode, he has been providing the IT support and the logistics for the entire. After Pappu Kumar Nayak, well, you must be aware, he conducted the hands-on session in the morning half, and everybody indirectly or indirectly who have helped, including the Pyare Mohan Deori, who is the website organizer for this park seminar. If he is there, he can just come up. And everybody other than these who have indirectly or directly helped me in organizing this conference. And so we now keep the, I'll share and I will provide if something needs to be contributed from my other coordinator, Dr. Partho.
No, it's okay. Thank you for joining this workshop. I think this workshop will be helpful for many of you who is want to pursue your research in this field. Okay, so thank you for participation. And if you have any other suggestions or any other comments you want to make, you can make it right now, maybe.
Yeah, so I keep the open. So if you want to have any suggestions, you want to add anything, any feedback, this is the time to do it. Anybody, anything you want to comment on or some new suggestion, I can ask my student also who is sitting here, Persona. He is also one of the participants. If he wants to say something regarding the conference.
And all the talks are really helpful, especially for those who want to pursue their research on Eutectic solvents in the future. And we also like all the
Okay.
the content is good, but you can understand.
Actually, I wanted this to be held physically, but because of this uncertain times and COVID-19, it has to be done like on an online manner. So anybody can speak out or give us some feedback. Or if you want, you can put your feedback on the form which we have just now circulated. So all the videos will be kept on YouTube. It will be shared on the YouTube stream. So you will get the links shortly after a few days. So those who have missed out a part, they can follow these lectures, and hopefully you can also take away any new information by following these lectures. Later on also, it will be there. So if there is no more comments to be made, I then officially declare the close. Okay, there is one. Yeah, Professor Mala, go on.
Yes, I will speak because no one is speaking. And
Okay,
I
yeah.
think that from the side of the participants and from the side of the speakers, we really need to thank you for the initiative and for the very well organized workshop. And thank you so much for letting us participating in it. So there is nothing or no recommendations for improvement. This was just perfect and was running quite well.
Yeah, actually, I should also thank all the speakers. Actually, I forgot. I mean, without your support, it's not been possible. The very short notice. Yeah. Anything else? Okay, so that's it then. We meet sometime. Maybe, and you must be, I think you must be aware we are having a DES conference again in 2021 in the month of June in Lisbon only. So the DES meeting, we will having much more different aspects of these lectures with variety of other research areas. So if everything permits, we can go there. You can also welcome there. You can also join this conference physically. So till then, I'll say goodbye to all of you from our team of organizing committee. Take care and stay safe. Bye bye.